Good morning. Myself Rakesh Yadav, representing Sandipani Higher Secondary School, Rajoda. I am your maths teacher and explaining class 12th related topic continuity of here one question of NCERT exercise 5.1. Question is, find all the points of discontinuity of f where f is defined by f of x is equal to, in first case it is mod of x upon x if x is not equal to 0 and it is equal to 0 if x is equal to 0. So, these two cases are given here. Not equal to 0, that in our previous lectures such type of question we have not done, that is why I am doing this type of question. If it is not equal to 0 means in case of less than 0 means LHL we have to consider this, and in case of greater than 0 we have to consider this only. X means x is not equal to 0 means either it is less than 0 or it is greater than 0, means for LHL and RHL we have to proceed it by taking this function, and for equal to 0 it is 0, it is defined at 0 directly as 0, this value at x is equal to 0, this value is 0 directly. So, now I am explaining it by two methods. First method, in modulus case, if we are doing this type of function, we have to assign this function f of x is equal to minus x upon x if x is less than 0. It is minus x upon x if x is less than 0, because it is not equal to 0 means either it is less than 0 or it is greater than 0. So, in case of less than 0 you will have to write here minus sign, minus x upon x, modulus sign will not be applicable in case of modulus. So, this x is cancelled by this x, it is minus 1, and at x is equal to 0 it is 0 only. Now, in case of greater than 0 it is positive x upon x if x is greater than 0, in that case it is positive x upon x. So, it is well clear now that if we are taking less than 0 then we, in modulus function we have to take the negative sign. In case of greater than 0, in case of modulus function we have to write positive sign, it is positive x upon x, and in case of x is equal to 0 it is directly given 0. So, these terms also we have to cancel. So, f of x is equal to minus 1, 0 and 1 if x is less than 0, if x is equal to 0, and here if x is greater than 0. These three conditions explain you one thing, that if you want to solve LHL then it will be limit x tends to 1 minus f of x, 0 minus, at 0 we are applying our continuity, at x is equal to 0 continuity test. So, at x is equal to 0 continuity test, LHL left hand limit x tends to 0 minus f of x, it is directly, you can see that 0 minus means less than 0, there is no x here. So, no need to apply f of 0 minus h and all those things. You may write it directly because it is the constant value, you may write it directly minus 1, and f of 0 that is equal to 0 only, because at x is equal to 0 it is directly 0 given. Now, in case of RHL we have to take limit x tends to 0 plus. If we are taking RHL means it is 0 plus, suppose this is 0, then this part is 0 plus and this part is 0 minus. It is the left hand side and this one is the right hand side. That's why it is left hand limit and this one is right hand limit. So, in case of left hand limit, it is minus 1. In case of f of 0, it is 0. In case of RHL, means limit x tends to 0 plus f of x. Directly we know here also that it is 1 because x is not there. So, this is the first method by which you can find limit in all the three cases, in LHL, in RHL and at x is equal to 0. Because LHL is not equal to f of 0 and it is not equal to RHL also. All the three values are different. LHL is minus 1, f of 0 is 0 and RHL is 1. So, because LHL is not equal to f of 0, it is not equal to RHL. Therefore, f of x is discontinuous at x is equal to 0. So, this first method is over. Now, second method I am introducing, in which if we are applying directly at x is equal to 0 continuity test. So, let us take LHL, that is equal to limit x tends to 0 minus f of x. It is equal to limit h tends to 0, which is our traditional method that I have told you already in our previous lectures. F of x, that is equal to f of 0 minus h, and it is equal to limit h tends to 0, 0 minus h mod of 0 minus h upon 0 minus h. So, it will be equal to limit h tends to 0, negative h is there in modulus, it will become positive, and here it is negative because 0 minus h is minus h, here it will become positive. So, it is directly minus 1. No need to write here on solving limit because this h is cancelled already. So, it is minus 1 directly. Now, in case of f of 0, it is 0 only. In case of RHL, limit x tends to 0 plus f of x. If it is not equal to 0, means it is left hand side, 0 minus means less than 0. That is why in left hand limit we have taken this function only, which is defined in front in above term. Now, if it is equal to 0, then it is written in our second part of the function, that is directly 0, and in RHL again this will be applicable because not equal to 0 means it may be greater than 0 also, it may be less than 0 also. So, now in RHL also we will take this function. So, it will be limit h tends to 0 f of 0 plus h. Now, we will have to write 0 plus h in this place of x in this function. In place of x we have to write 0 plus h in this function only. So, now it will be limit h tends to 0, 0 plus h upon 0 plus h. It will be equal to limit h tends to 0, Remember one thing, modulus means negative will become positive in case of modulus. So, here it will become positive. In case of positive, it is positive, but due to denominator, here it will become negative. That is why it is minus 1. In case of RHL, here it is 0 plus H, here also it is 0 plus H. Both terms are positive H. So, H upon H, that is H is cancelled 1. Here only the denominator is negative, but the numerator is positive because modulus function it is. That is why it is positive. Otherwise, if it is not having modulus sign in function, then it will be 1 only. So, it will be H is cancelled by H. Directly you may write 1. No need to write on solving limit because there is no need to put any value of H there. Now, see, this is our LHL, this value is minus 1, this is our f of 0, this value is 0, and this is our RHL, this value is 1. So, LHL is not equal to f of 0 and it is also not equal to RHL. Therefore, f of x is discontinuous at x is equal to 0. Now, again one more question related to modulus I am explaining. It is question number 9 of exercise 5.1 only. Find all the points of discontinuity of f where f is defined by f of x is equal to x upon mod of x if x is less than 0 and it is equal to minus 1 if x is either greater than 0 or equal to 0. So, let us apply the continuity test at x is equal to 0. We are applying continuity test. One more question arising in your mind, I think so, that why we are applying continuity test only for finding the points of discontinuity? Of course, because by we know only continuity test, and by applying continuity test, if it is not continuous, then we may write directly discontinuous, that this function is discontinuous at a particular point, and if it is continuous, then we may assign it that it is not having any discontinuity point. So, at x is equal to 0, that is why we are applying continuity test. LHL, that is equal to limit x tends to 0 minus f of x, that is equal to limit h tends to 0 f of 0 minus h. Means in place of x we have to assign 0 minus h and 0 minus h in numerator and denominator both. So, limit h tends to 0, 0 minus h upon mod of 0 minus h. In this question, modulus is represented in denominator. That is why we are applying modulus function in denominator only. Here this negative h will become positive. 0 minus h is minus h, but here it is positive h because modulus is in denominator. That is why limit h tends to 0, it will become minus h upon positive h. Here negative will become positive due to this modulus sign. So, h is cancelled. No need to write on solving limit because h is only cancelled. No need to solve the limit also. So, we may write it directly minus 1. Here it is minus 1 that we have solved, means LHL we have solved. In case of RHL and in case of equal to 0, it is minus 1 directly. So, first of all we have to assign f of 0. This is directly given minus 1 because in here it is equal to sign. So, in case of x is equal to 0 directly, it is f of 0 is equal to minus 1. Now, RHL is equal to limit x tends to 0 plus f of x, that is equal to limit h tends to 0 f of 0 plus h, or which you can write for greater than 0, directly you can write minus 1. Here also you may write minus 1 because 0 plus case means this, or you may write after this step also minus 1. So, here we have seen that LHL is equal to f of 0 is equal to RHL. All the values are minus 1. See here, this is our left hand limit, this is minus 1. This is our f of 0, this is also minus 1 by this given function, and this is our RHL, which is also directly 0 because for greater than 0 means 0 plus case, it is minus 1. So, LHL is equal to f of 0 is equal to RHL, means this function is continuous at x is equal to 0. So, you may write now no point of discontinuity. For above given function. Means if we are applying discontinuity test, so we will have to write it in this manner, no point of discontinuity for above given function, because it is continuous here. So, we have to write, we have to mention this always. Now, one more question, it is question number 10 of the same exercise 5.1. Find all the points of discontinuity of f where f is defined by f of x is equal to x plus 1 if x is greater than or equal to 1, and it is equal to x square plus 1 if x is less than 1. So, these two cases we have to discuss. So, point is at x is equal to 1, continuity test we have to apply. LHL, that is equal to limit x tends to 1 minus f of x, means for less than 1. Here it is x tends to 1 minus. See this question, always less than part is represented in above term and greater than term is written in below term of this function of x. But in this case, LHL is defined in below given part of the function. So, this you have to remember, this type of things also happen, that it may cause any mistake in your examination. So, limit x tends to 1 minus f of x, it is equal to limit h tends to 0 f of, here it is 1 minus h, because it is assigned as 1 minus. So, on changing limit, we have to write 1 minus this h, 1 minus h. So, now we have to put 1 minus h in this part. Why is it so? Because x is less than 1. Less than 1 means it is left part of the number line in case of less than 1. So, it will be limit h tends to 0, 1 minus h whole square plus 1. On solving limit, this will become 1 minus 0 whole square plus 1, that is equal to 1 plus 1. So, it will be 2. This is our LHL. Now, f of 1, f of 1 means it is equal to 1, LHL means it is less than 1 and RHL means greater than 1. So, for f of 1 means it is equal to 1, for equal to 1, this is the given function, and here we have to write 1 in place of x. So, it will be 1 plus 1 directly, because in place of x we have to directly write 1 in this part of the function. So, 1 plus 1, because here it is only equal to sign. So, f of 1 is equal to 2, means LHL is equal to f of 1. Now, RHL is equal to limit x tends to 1 plus f of x, that is equal to limit h tends to 0. Here we have to write 1 plus h in place of x. So, it will become f of 1 plus h. Now, limit h tends to 0. For greater than 1, this is only the function. So, it is 1 plus h plus 1. On solving limit, it is equal to 1 plus 0 plus 1, means 1 plus 1, that is equal to 2. So, LHL it is 2, f of 1 it is also 2, RHL it is also 2. So, LHL is equal to f of 1 is equal to RHL. So, it is continuous at x is equal to 1. No point of discontinuity. No point of discontinuity is there in this function also. So, this type of question is over.